everyone, I'm Ian. I do DevRel for World, and I'm here to tell you about building for real humans. So we have this one really big important question here. How do you know who is a real and unique person online? You might think about CAPTCHAs or things like that, but it's really hard to solve this problem in a really powerful, strict way. But that's what we built World ID for. World ID is our proof of personhood protocol, letting your application know that this user is a real human with only one account, but with that user not revealing anything about which real human they are, right? So I'm a unique human. I'm doing an action only once, or really however many number of times you want, and optionally with this tamper-proof message that we call the signal. We've built World ID to be private, inclusive, and robust. We don't want the user to have to reveal extra information about who they are. We want as many real humans as possible to be able to use this technology, and we want to make sure that it's robust, ensuring that every real human only gets this one account. And when we think about how to meet all of those requirements, with email and phone numbers, they don't work super well. I have many emails, I have multiple phone numbers. We might think that KYC of official government IDs is the way to go, but less than half of the global population has a digitally verifiable government ID, so it's not scalable enough for us. Web of trust systems also don't scale to all of humanity in their current implementations very well. Most web of trust systems start with an initial trusted set of 100 or 1,000 people, but scaling that to 8 billion doesn't really work that well, because every hop away from that initial trusted set you are in a web of trust is really the less trusted you can actually be. And so we settled on using biometrics because they can be unique to every human. There is obviously the human component of biometrics at all, but there's multiple different biometric factors that we can use. We looked at fingerprints, palm scans, face scans, right? Things that you might be more familiar with for Touch ID or Face ID on your phones. But those actually don't have enough entropy to determine uniqueness at the scale of all of humanity, right? Face ID on my phone can distinguish about 1 in a few million people, which is totally fine for unlocking my phone. I like those odds a lot, but 1 in a million for determining if you're unique amongst all 8 billion or so humans that exist breaks down really, really quickly. We also took a quick look at DNA, right? It's very, very unique to every individual, but it can't be done in a private manner, right? There's no way that we could say we don't know anything about who you are if there's DNA involved. So ultimately, we settled on using the iris, which has a lot of entropy. It's unique to every human, even identical twins have very different irises. And it's also something that requires a level of consent, right? You can close your eyes if you don't want someone to see your iris. It's not something that can be scanned passively while you're walking past on the street. Your face could be. You're not leaving fingerprints or palm prints everywhere like you are on glasses at restaurants and things like that. So then how do we actually use these iris biometrics? Phone sensors just aren't high quality enough. There's one phone I'm aware of that did have an iris scanner for unlocking. It was very easily broken with some hard contact lenses and printing an iris on a piece of paper. We looked at off-the-shelf hardware, like what Clear uses at airports in the United States for a faster line through security, but they're really big, they're expensive, they don't meet the requirements that we have. So we became a hardware project and had to build custom hardware, just because we care about solving this problem as effectively as we can. And that hardware is the orb. So the orb has a couple different sensors on it. Its job is to first make sure you're actually a human, running over a dozen machine learning models locally on the orb. It takes a photo of each iris and calculates this iris code, this digital representation of the pattern of your iris. And that's what we use to check and make sure that you're unique. These iris codes are stored in this really fascinating MPC system If you want to learn more about like the cryptography behind that, how we do this super privately and super safely and securely, I'm happy to chat about that at our booth after this workshop. But once we know that iris code is unique, your World ID gets verified. And your World ID is essentially just a key pair in World app on your phone. Verifying it means that the public key goes into a Merkle tree on Ethereum mainnet. It's essentially just the list of verified World IDs. And we built this whole system to be privacy first, decentralized, and open source, right? Everything about the protocol is open source. The majority of the Orb hardware and firmware and software is open source. I can go more into decentralization at the booth, like too many like great things to talk about in this short workshop. And when it comes to actually using World ID, like what it makes sense for, Sybil resistance and bot resistance make sense for a ton of different use cases, right? The protocol that World ID is built on top of, Semaphore, was actually built with like voting in mind as a key use case. Obviously, social media makes sense, right? Twitter sucks because of how many bots there are. And it would be great if you could know that there is like a real human and this is their account. Customer incentives are one that I particularly like. Netflix used to have their 2-week free trial every time a new account was made. So people just spun up more and more email accounts to get this Netflix 2-week free trial and never ended up paying for Netflix. Netflix doesn't like it when people don't pay them, so they got rid of the 2-week free trial. But with World ID, they could offer a 2-week free trial or even longer, maybe a month, maybe 3 months, knowing that you as a real human only get that one free trial, and then you also get the free trial back just for being a real human. But when it comes to all of these use cases, how do we actually like get these use cases into the hands of people who have been verified with World ID? And that is mini apps. So we recently announced mini apps at a keynote in San Francisco last month. And mini apps are these applications that open inside of World app, where you can interact with World ID and have users verify like they would in an external app, just with a better user experience. They don't have to switch applications or anything like that. And for the first time, external apps not built like by a World project can interact with the wallet in World app. So you can do things like sending payments or even just general transactions, interacting with any smart contract you want on World Chain, our own OP stack layer 2. And additionally, we can give these applications distribution to our millions of verified humans in World app. World app has over 15 million users, over 7.5 million of which are verified at the Orb. And your app can be listed in this app store, and if it's especially great, it can be highlighted on the homepage of World app in like a card so that users can hear about your app for the first thing that they do when they open World app. So how do you actually build a mini app? So every mini app is a web view in World app, right? It's essentially a PWA, but instead of added to your app's home screen, it's accessed through World app. And we built a new SDK called MiniKit specifically for these mini apps. So something I'm not showing in the workshop, but is like the first thing in our docs that you'll see is actually installing MiniKit. You'll wrap like the main body of your like JavaScript app in the MiniKit provider so that you can access this MiniKit object globally. So to start, let's see like what it looks like to actually verify with World ID in a mini app. When you first configure MiniKit and like set up that provider, it will already have your app ID as you've set up in our developer portal. So for this verify input, we need the action the user is going to verify for in that app, the signal if you choose to use one, right? As an example of what you might actually use that signal for, if your user is, say, voting on a poll in your mini app, that signal might be which poll option they selected, because that signal can't be tampered with between when this verification is generated on the user's phone and when that proof is later verified with our developer portal API or with our smart contracts on chain. So it's optional, definitely not required, but useful in a lot of circumstances. And then this verification level defines which World ID credential your user is required to have. I've already talked about the orb credential. We see that as sort of the gold standard for knowing your user's a real human with only one account. But there's also the device verification level for off-chain use cases, where World App has checked that it's running a legitimate version of the app on a real phone, not a virtual machine, and that it's not in an app cloner environment. So instead of knowing it's a real human, you at least know it's a real device. If I want to try to Sybil attack your program with that device verification level, I'm going to have to buy a lot of $50 Android phones or something like that. So it's definitely a weaker credential, but one that every real world app user has, whether or not they visited the orb, and is much more scalable. So I've configured all of these things for this action I want the user to verify for. And then I define this handle verify function here, which I'll just call whenever the user clicks a button in my app to actually go ahead and verify with World ID. We'll first just check to make sure that Minikit is actually installed and configured. And then we issue this async command to Minikit. So this verify command takes the input we defined earlier. That promise resolves when the user has completed the flow of tapping verify in the app or declining to verify by tapping out of the modal. And then we get this payload. So this payload will have a status field that'll be success or error, just to see if the user actually went through with the verification or if there was something that prevented them from doing it. And then we take that payload and we have to verify that proof, right? So that payload actually, also has the success field. This is ripped from an older workshop, sorry. But it has that success field or error field, and then this is the actual zero-knowledge proof that was generated on the user's phone. The Merkle root is actually the root of the tree that the user generated that proof against, right, gotten from Ethereum mainnet. The nullifier hash is the identifier of that user in the context of your app ID and action ID, right? So if I try to do the same action twice, I generate the same nullifier hash, which is how we actually implement that Sybil resistance. But if I do two different actions, there's two different nullifier hashes, and there's no way to tell that those two nullifier hashes actually belong to the same real human. And that's how we have this privacy, where it's not revealed which user is verifying, just that one of these real users is verifying and only doing it once. This proof is this very long hexadecimal string that's mathematically the zero-knowledge proof itself, and then which verification level that proof was generated for. So in this example, we'll verify this proof with our developer portal API. So you'll define a route on your app's backend that will receive this proof. So here we're just passing that proof, the action, and the signal, if you used one, to your backend. And if that backend function that I'll show in the next slide does verify correctly and your backend returns this positive response, then you should just go ahead and redirect the user to the next page because you know they're verified now, or else show them some sort of error. To actually verify your app in the backend, we have this helper function called verify cloud proof that will take in the proof, the app ID, the action, and the signal, and handle calling our developer portal API to verify that proof. So you'll either get this successful response or an error response. If it's successful, in your backend is where you should mark the user as verified in your database or something like that, right? But you want to take some action with that successful result in your backend because your backend is a secure context. If you were to just pass that successful result back to your front end and then try to mark the user as verified from there, right, and make another call to your backend to change the database or something like that, the user would be able to manipulate that information in the front end so that even if they verified unsuccessfully, they can then just change it to say it was successful. So you have to like keep certain things within the secure context of your backend. But this is like literally the whole like backend code here. It's super simple. But you can also verify these proofs on chain. So in your smart contract, right, in this example, let's say there's just one like action for your whole app that the user wants to perform. In your constructor, you'll pass in the address of the World ID router. You can find that in our documentation for World Chain. Is supported on other chains, but for mini apps, you can only use World Chain, so that's all I'll talk about here. And then you'll pass in the app ID and the action ID. So we'll have this World ID as just like the instance of the World ID router contract. This external nullifier is a combination of the app ID and the action ID. That is what actually determines like the uniqueness of an action. It's more of an underlying protocol thing that's just needed when you're verifying these proofs on chain. So just rip that code from our templates that I'll show you later and reuse it. You don't need to modify it or worry about it too much. And then in this function, which is just verify and execute, right? What you're actually executing is sort of undefined here. That's up to you. We'll pass in the signal, the Merkle root, the nullifier hash, and the proof that we got from that like proof object when the user verified in your mini app. You'll note that we don't take in the verification level here like we did for the backend verification, and that's because only the orb credential is supported on chain. That device credential is not supported on chain. So if you want to do that device verification level, your app has to be off chain for that proof verification. So the first thing we'll do when we get this proof in our smart contract is check if we've seen this nullifier hash before. So we'll have this mapping of nullifier hash to a Boolean. That nullifier hash is a 256-bit unsigned integer. So if this nullifier hash already maps to true in that mapping, then we revert with this invalid nullifier like event. And that just means the user's already done this action. We don't want to let them do it a second time. If that isn't set to true, the user hasn't done this action before. So then we'll continue and call the verify proof function on the World ID router smart contract. So we'll pass in that root. The group ID defines like which credential we're working with. For the orb credential on chain, that is always 1. We will hash the signal in a specific way for that verification with the smart contracts. That hash to field helper function is defined in our templates as well. We pass in the nullifier hash, the external nullifier that we set in our constructor, and then the proof. If this proof doesn't verify for whatever reason, maybe the signal didn't match up with when that proof was generated or something like that, this will revert. Otherwise, it simply continues. It doesn't return anything. So you already have that like flow control there built into this verify proof function. So if that doesn't revert and continues, then we should make sure that we mark that nullifier hash as used to prevent the user from doing this action again in a separate transaction. And after all of that, that's where you should put your logic of what you want to allow the user to do behind World ID. That might be minting a token to them. That might be claiming an NFT. That's totally up to you. That's what's up to your application. But you should verify the proof at the start of this function, and after that proof is verified and the nullifier hash is marked as used, that's when you go ahead and do the thing that requires World ID. And how do you send these transactions with MiniKit? So, as I mentioned, with MiniKit, everything happens on World Chain, our own OP-Stack L2. And in World App, we have some like fancy functionality for covering all the gas of our users' transactions and batching all of them together. So you can't send these transactions with typical tooling like WAGME, for example. But we have this send transaction command for MiniKit. And when you want to send this transaction, similarly as earlier, because it's an async command, that promise will resolve when the user actually completes the flow, either tapping send transaction or clicking out of the modal. You'll specify the address of the contract to interact with on World Chain. You'll have the ABI of that contract, which you can either import or just define inline if you really want to. You'll have the function name, right? Verify and execute as we had in our contract. And then you'll put in all of the arguments for that function that you're calling. So in this case, for verify and execute, we have the wallet address of the user as the signal. We have the Merkle root, we have the nullifier hash, and then the proof you have to split up into an array of 8 256-bit unsigned integers. It's a little wonky, but again, you can just use the code from the template that we'll provide. So sending transactions with Minikit is fairly easy. One thing to note is that if you want to have a transaction that involves sending a token that isn't ETH, you do have to use permit2. Our documentation will go into this because for the user experience, we'll have you request the permit2 in the same send transaction command. And then on the World app side, it's actually just one tap for the user to send that transaction that will generate that permit2 signature and then send the transaction with that signature included in order to allow those tokens to be transferred by the smart contract. So that's sort of the quick rundown of how to build with a mini app. We have 20K worth of bounties available, and we're giving $10,000 to the best mini app. $5,000 to second place, $2,500 to third place. We are all in on mini apps at this hackathon. We want to see these mini apps get built in this 36 hours, and ideally be shipped to the mini app store in World app. We want to see these real things be built that we can put in front of users and show them what they can use their World ID and their funds on chain for. We're committed to providing support after the hackathon to help you polish and grow your application. And Leighton, will you raise your hand? He does ecosystem for us. If you really want to chat about a lot more stuff you can do with mini apps, he's a great person to talk to about everything that isn't a technical question relating to mini apps. That $2,500 pool prize will be split equally among all projects that submit for our bounties and make a good faith effort to build a mini app, but don't receive one of these larger prizes. And all the documentation you need for mini apps you can find at docs.world.org/mini-apps. And thank you so much. So he was asking if you need to be a verified user in order to use the app. No. So you can download and install World app without ever verifying at an orb. You'll have that device verification level, right? You can still use the wallet, you can still use the mini apps, but if a mini app requires that you verify with that orb credential, you won't be able to verify for that specific thing. But you can still use all these mini apps, you can build all these mini apps without verifying. We do not have any Rust support for mini apps, to my knowledge, at the moment.
Is there a way for your application for WorldCoin to know if a person is registered anywhere? For example, if we are installing anything, a person is registered, yes or no?
So wait, is the question if will you just repeat the question? I'm sorry.
Say you are using an orb and you are verifying that you're yourself, but you don't have your cell phone. Is there a way to verify that that person has already been onboarded into WorldCoin?
So, to make sure I understand it, the question was if someone doesn't have their phone with them, is there a way to verify with the orb that user is already orb verified? Not for your application. The orb will reject a second verification for that user. So they wouldn't be able to verify again, but your application can only like verify that that user has a world ID when they can generate that proof.
Okay, I think my question. Okay, better way to explain my question. Can I know if a person has been registered to WorldCoin or not? Or not?
The way that you can know if that user has been verified or not is by making them like verify and generate that proof, and then your app verifies that proof. Correct. You can only prove that you are verified. You cannot prove you are not verified. How hard is it to set up a new orb station in a country? So today, Tools for Humanity manages orb operations for most of the world. Next year, we'll have this community operator program where people will be able to like buy or rent an orb to operate in their local communities. We announced that at the keynote in San Francisco last month. Still fleshing out a lot of details there, but it will be easier to bring orbs to new countries starting next year.